Suppose we wish to know how many solutions of this equations are in set of real numbers. Then notice that x square is equal to x into x. This I have already proved that this is same thing as product of their multiplicative inverses, and this product is further equal to minus x square. So it means if x square is equal to a, then minus x square is also equal to a. So it means there are two solutions for this equations. X is one solution and minus x is another solution. From this we see that the positive value of these two solutions, so either x will be a positive number or minus x will be a positive number. The root a will be a positive value of x satisfying x square equal to a. Further, taking square root both sides, we get x square and its square root. This thing is equal to square root of a. We shall define square root of x square as mod of x. Also, another equivalent way of writing this mod x is, so this number is x if x is greater than or equal to 0. This thing is minus x if x is less than 0. So I will show that these two things are same. So first let us realize this thing by using some example. Let x is equal to 5. Then mod x is, now use definition. If x is greater than or equal to 0, mod of x is x. Now 5 is greater than 0, so mod 5 is 5. So mod 5 is equal to 5. And if x is equal to minus 5, then mod of minus 5, now use this definition. So when x is less than 0, now minus 5 is less than 0, so mod of x when x is less than 0 will be negative of that number. So take negative of this number, so this is minus of minus 5, which we have already seen that minus of minus x is x, so this is 5. So in both cases, either x is a positive number or a negative number, mod of x is a positive number. So this number is a positive number. And here my definition of root a was the positive value of square root of this. So there are two answers satisfying this equation, but I have said that the positive value of x satisfying this relation will be root x, will be root a. तो ये फॉलो हो गया यहाँ से कि अगर रूट ए किया तो ये नंबर पॉजिटिव आएगा. इस पॉजिटिव नंबर का नाम मैंने ये मॉड एक्स रखा है, और मॉड एक्स के लिए एक डिफरेंट वे ऑफ राइटिंग लिखा है तो अब मैं इस डिफरेंट वे से भी आपको बता दिया कि ये चीज़ पॉजिटिव आएगी चाहे मेरा x नेगेटिव है या पॉजिटिव है. सो दीज टू डेफिनेशंस आर सेम. So regarding square root, one axiom is if a, b are greater than or equal to 0, then if a, b are greater than or equal to 0, two real numbers, then square root of a, square root of b are defined and square root of ab will be equal to square root of a into square root of b. This relation is true when a and b are positive numbers. This is our axiom. I'll show you that if a and b are negative numbers, this relation is not true. If a equal to -1 is equal to b, then above equation gives square root of -1 into -1 is equal to square root of -1 times square root of -1. So this implies -1 into -1 is +1. -1 square root, you know, this is iota, this is iota. So this is square root of 1 is 1. This is iota square, which you know is -1. So 1 is equal to -1 if I assume this relation for negative values. So this relation is true, is assumed to be true for the set of positive real numbers. So now using definition of mod x, I'll prove some results. Number one result, I'll prove if x and y are two real numbers, then x y mod is equal to mod x times mod y. Second, I will prove if x and y are two real numbers, then x plus y mod is less than or equal to mod x plus mod y. So proof 1. So mod of xy, now use this definition. Mod of xy is xy square and its square root. So this thing is equal to square root of x square into y square. So I have already proved that x square is a positive number, y square is a positive number. For positive values, the square root is assumed like this, square root of a into square root of b. So this is x square times y square root, but this is equal to mod x times mod y. So we have proved that mod of xy is equal to mod x mod y for all xy belongs to set of real numbers for f. So if x is negative, x square is positive. Similarly, if y is negative, y square is positive. These two numbers are positive, therefore I can go from this step to this step. Otherwise, I can't go from here to here if any of these numbers is negative or both of these are negative. So second, x plus y mod, which is equal to x plus y. So from this equation, if you square this equation both sides, you will see that mod x square is same thing as x square. So I start from here. So x plus y mod square is same thing as x plus y square. So this result follows from definition. So a plus b whole square, you know, x square plus 2xy plus y square. Now notice that x is always less than or equal to mod x. So if x is a positive number, then mod of x is x. So these two sides will be equal if x is a positive number. But if x is a negative number, this side will be negative. But mod of negative number is a positive number. So positive number will be greater than the negative number. So x is always less than or equal to its mod. So here I don't write equality. Now I write less than or equal to. In place of x square, I write mod x square. For 2, I write 2. But for this x is less than or equal to mod x. For this y, less than or equal to mod y plus mod y square. Clear? So this thing now equal to mod x plus mod y whole square. Now taking square roots, we get the desired result. Mod of xy will be less than or equal to mod x plus mod y. Here we have less than or equal to sign. Thank you. In the previous problem, I have used this relation a less than or equal to b implies root a less than or equal to root b, where I had this equation x plus y mod square is less than or equal to mod x plus mod y whole square. Then I said that take square root and you will get the desired result. So here I have used this result that whenever a less than or equal to b, a, b are positive or 0, then a less than or equal to b implies root a less than or equal to root b. So I will prove this result also, because this result I have used here in proving my previous result. So let's see quickly what this result is and how to prove it. Proof. So a less than b implies b minus a is a positive number, that is b minus a is greater than or equal to 0. So b minus a is either a positive number or b minus a is a 0. Now use definition of mod x here. So recall that mod of x is square root of x square. So if x is greater than or equal to 0, then mod x will be x. This was my definition. And this thing is equal to, I can write this as x into x square root. But I can split by square roots because both of the numbers are non-negative. Therefore, I can write this thing as root x times root x. So this thing is equal to root x square. So root x square is x. I will use this fact here. So this implies b can be written as root b square. A can be written as root a square is greater than or equal to 0. So this implies now a square minus b square, we can make two factors, root b minus root a into root b plus square root of a greater than or equal to 0. The product of two things is non-negative. this I have already shown that either both of these things are positive or both of these are negative, and equality will hold if one of these is a 0. But this possibility is not possible here, because by my definition root of a is a positive number, root of b is a positive number. So positive plus positive, this thing is positive. So if this thing is positive, this has to be positive. So this implies root b minus root a is greater than or equal to 0. This implies root b is greater than or equal to root a. That is, root a is less than or equal to root b. So I used this result in my previous question. That's why I had to prove this one also. So x plus y mod is greater than or equal to mod x minus mod y. So see its proof. So consider mod x as mod x plus y plus its additive inverse. So y plus its additive inverse is additive identity, 0 plus x plus additive identity is same as x. So this thing is equal to, now use our previous result, consider this thing as a and this thing as b. Mod of a plus b is less than or equal to mod a plus mod b. So this is mod x plus y plus mod b, that is mod of minus y. But mod of minus y is same thing as mod of y. Now bring this mod of y in this side, we get mod x minus mod y is less than or equal to x plus y mod. Definition of an interval. So there are 4 kinds of intervals. Number 1, open interval. So what is this? So if a less than b, then the set S consisting of all real numbers x such that a less than x less than b, this set is called an open interval, and this will be denoted by a to b. This set consists of all numbers which are greater than a and less than b. So in this set, a is not here, b is not here, and notation is this round bracket a and round bracket b. It means we are taking all real numbers between a and b, but we are not taking a and b. Second is closed interval. Again, if a is less than b, then the set S dash is all x such that a less than or equal to x is less than or equal to b. Now take all real numbers between a and b and take a and b also. This set has this notation: square bracket from a to b. So this set consists of all elements starting from a and ending at b. The another two intervals are semi-closed or semi-open intervals. So consider this thing, square bracket and round bracket in this side. So this is set of all x such that a less than or equal to x and less than b. The point a is included in this set and b is not included. Similarly, if here we have a square bracket and here round bracket, then we have equality sign here and strict inequality in this side. Definition is bounded set. So now we have a notion of real numbers, less and greater, positive and negative. So now I can define a bounded set. A set S which is subset of R is called bounded above if there exists some real number m such that x less than or equal to m for all x belongs to S. That is, so if every element of set S is less than some fixed number, then the set S will be called bounded above. Second definition is of bounded below. If there is some real number small m such that x is greater than or equal to m for all x belonging to S, then S is called bounded below. For example, set of real numbers are bounded below by 1 because every natural number is greater than or equal to 1. Or we can say that set of natural number is bounded below by 0 because every number is greater than 0. All negative integers are bounded above by 0 because every negative integer is less than 0. So if a set is bounded above as well as bounded below, then that set is called a bounded set. So set of natural numbers is not bounded because it is not bounded above. Set of negative natural numbers is not bounded because it is not bounded below. So bounded set means a set which is bounded above as well as bounded below is called a bounded set. So now, what are examples of bounded sets? So for example, consider interval 1 to 2. So this is a bounded set. So what is this set? This is all x which are greater than or equal to 1 and less than or equal to 2. So since every element of this set is less than or equal to 2, it is bounded above. Every element is greater than or equal to 1, it is bounded below. Therefore, it is a bounded set. So I can take 0, 10. This is all x x is greater than 0, less than or equal to 10. This is again a bounded set. Every element of this set is greater than 0 and every element of this set is less than or equal to 10. Therefore, this set is bounded below as well as bounded above. Therefore, it is a bounded set. So, this is also a bounded set. So, this is all about the definition of a bounded set.